So, question 11. Light bulbs have a mean life of 125 hours and a standard deviation of 11 hours. We're going to find the probability that a randomly selected light bulb lasts more than 140 hours, less than 100 hours, and then the probability that lies between 100 and 140.
Sorry to interrupt, sir. You might use this off your desk, and do you have any more in that plan?
Try the back of the room.
Yeah, sure.
Okay.
I'll use these ones too.
So, we could graph this and use the integration and find, the mu was 125, and this is going to be 100 hours, and then 140 hours is here. Okay, you could integrate and just find that. Okay, completely legitimate. Today we're going to use tables. So, we need this is the x scale, right? That's the x scale. And the origin is down here somewhere. Okay. What we want to do is we want to convert this into the standard. The z-scores, that's right, the standard normal distribution. Now, what is mu on the z-axis? It's always 0, isn't it? Okay, then you've got 1 standard deviation, 2 standard deviations, 3, -1, -2, -3. Okay, so in terms of comparing the standard to the normal distribution can have negative values for x depending on its context. Okay, so if we're talking about depth above sea level, depth below sea level, you could have negative values here. Okay, the z-axis is always starts at 0, always. Okay, this would be 1 standard deviation, 2 standard deviations, 3 standard deviations, negative standard deviations. Yeah? And the other thing to note is that there is such a thing. There is such a thing as 5 standard deviations above the mean. Okay? We can't really see it with the naked eye, but it does, the concept of it does exist because this continues forever, doesn't it? Okay? Don't use it, don't see it very much, but it is there. Alright, so let's get into this. What is the z value for x at 140 hours? 1 you reckon. Okay, so you reckon it's right there at 1 standard deviation. Okay, well let's check it. Z is equal to x minus mu, so divided by sigma. X in this case is 140. Take away mu, which is 125. Divide that by 11. And we want a decimal. What's that going to come to?
1.36.
3636.
Yeah.
Good. We go to our tables, and Christina, do you have it there? You do? Okay.
Yeah.
And how much does it come to? Phone in, girls.
0.9131.
0.9131. Okay. Now let's just pause there for a second. Here is 1.3636, and we want the area that is greater than. We want this area here, right? And the tables we're using is actually going to give us that area there. Okay, so we're going to have to do the 1 subtract that area. Yeah, so this is equal to 1 subtract the probability that z is less than 1.3636. Yeah, you guys still with me? All right, and Christina, what was the probability of that?
0.9137.
Good. And now we can just do our subtraction. You shouldn't need a calculator for this step. 0.0863. Okay. Right. Let's do the next part. We're going to find the probability that a light bulb lasts less than 100 hours. Okay. So we put in our z-score. 100 take away 125. What's going to happen to our answer?
Be negative.
It's going to be negative, that's right. So we're looking for a z-score on this side of the mu. And divide by 11, and comes to negative 25 divided by 11. We need a decimal. What's it come to?
Negative 2.27.
2727, yeah, you always use 4 decimal places. And we can draw that. And so there's mu at 125 hours, or 0 on the z-axis. And negative 2 standard deviations is about here. Like so. Okay? So always good to note that z, we can say z has a unit, and the unit is standard deviations. Okay, this is negative 2 standard deviations from the mean. Right, so we're looking for the number of bulbs less than 100, so it's this area we want. Okay, we don't want this. And our z tables, our tables give us only positive values for z, so we're going to have to use our reflections and say negative 2.2727 is also the same as this area here. True? That area is the same as this area. So we'll use the reflection and say this is 2.2727. We want this area, not that area. We'll do the 1 subtract. So the probability that x is less than 100 is equal to the probability that z, that 1 is less than the probability of z being less than 2.2727. And now we need to look this up in our table. And what's the percentage?
0.9885.
0.9885. Very good, Aidan. I concur. And this comes to 0.0115.
It's between the table, right? No, don't worry.
Okay. Here, we'll hang on to that question, okay? 1 to go. Now this part's going to be nice and easy. So we worked out in part A that the probability that is greater than 140 hours was 0.0863. We worked out the probability that the light bulbs last less than 100 hours was 0.0115. So how do we find the probability of the middle region? We just subtract it from 1, don't we? So this area here is equal to 1 subtract 0.0115 subtract 0.0863, and that will come to 0.9022. Yeah? Wonderful. Looks like you all understood that. That's great. It's really interesting, isn't it, that we can apply the normal distribution to nearly, well, to so many different context, light bulbs, or the length of a battery life. You know, you have your mean, and then you have your the percent probability that it starts to die out or last longer. Okay, what was that?